Hey everyone, welcome back. Today we're diving into something you, the listeners, have been asking about a lot. Perception.
Yeah, it's a really popular one.
It is, so we're going to unpack Chapter 2 from this cognitive psychology textbook we've got. It's all about how we make sense of the world around us, which, as you can imagine, gets pretty complex.
Oh, absolutely.
Yeah, and the chapter is packed with all these theories and research studies, even some optical illusions.
Oh, those are always fun.
They are fun. But our mission today is to kind of sift through all that and pull out the most interesting, the most mind-blowing insights about how our brains actually work, right?
Yeah, let's get into it.
How do we take all that sensory information and turn it into something meaningful? And how easy is it to trick our brains into seeing or hearing things that aren't really there?
Easier than you might think.
I bet. So the chapter kicks off with this kind of basic distinction between sensation and perception.
Right, because those two often get mixed up.
They do, yeah. People use them interchangeably, but there's a key difference, right?
For sure. So sensation is like the really basic raw data coming in from our senses. Like think about light hitting your retina or like sound waves vibrating your eardrums.
Okay, so just like the physical signals.
Exactly. But then perception, that's where it gets interesting. Perception is how our brain actually interprets all that raw data. It turns it into something meaningful that we can understand and respond to.
So when I see a delicious plate of cookies, the light bouncing off those cookies hits my eyes. That's sensation, right?
Right.
But then my brain recognizing them as chocolate chip cookies and then maybe even triggering a craving, that's perception.
Exactly. It takes that raw sensory data and then uses our knowledge, our memories, even our expectations to create like a cohesive experience. It lets us actually experience the world, not just sense it passively.
Okay, so it's way more complex than just seeing or hearing.
Oh, yeah, for sure.
So then the chapter goes on to talk about bottom-up and top-down processing. I'm guessing this is about how we actually make sense of all that sensory information, right?
That's exactly it. So bottom-up processing is all about the data. It's data-driven. You're starting with those individual pieces of information, and then your brain is working to piece them all together to see the whole picture. It's like starting with a puzzle. You only have the pieces.
Okay, so if I'm trying to identify, I don't know, a bird outside my window, my eyes see its shape, its color, its movement, and then my brain combines those details to recognize it as, let's say, a robin.
Right, exactly. You're taking all those individual sensory details and you're building up to a full perception of what you're seeing.
Got it. And then what about top-down processing?
So top-down is like having the lid of the puzzle box, to guide you. It uses our knowledge, our expectations, everything we already know about the world to help us interpret that incoming sensory information.
Okay, so if I hear a meow, I'm probably going to expect to see a cat, even before I actually see it.
Precisely. That expectation, it basically primes your brain to interpret the sensory data in a very specific way. So bottom up is all about the details, top down is about the context and the meaning.
So these two processes, they're working together all the time.
All the time, yeah. It's like a constant interplay, and that interplay is key to understanding how we perceive the world around us.
This is fascinating. So our brains are doing so much work behind the scenes that we don't even realize. And then there's this thing called Gestalt principles of organization that the chapter talks about. What are those all about?
Ah, Gestalt principles. So these describe how our brain likes to organize visual information, right? It wants to find meaning, it wants to see patterns, it wants to make sense out of sometimes what is just chaos.
So instead of seeing just a jumble of shapes and colors, our brain tries to impose order on it.
Yeah, exactly. And it does that by following certain principles like proximity. So things that are close together, we perceive them as belonging together.
Right.
Or similarity, objects that look similar, we group them together. And actually, these principles can even explain why camouflage works so well.
Oh, that's interesting. How so?
Well, think about it. Camouflage, it kind of disrupts these grouping principles. If you've got like a tiger's stripes, they break up its outline, right?
Yeah.
And it makes it harder for our brain to perceive it as a distinct figure against the background.
Oh, so it's like the puzzle pieces no longer fit together neatly.
Exactly. Yeah, it makes it harder to see the whole picture.
That's a really cool way to think about it. And then there's figure ground segregation, right?
Yes, so this is our brain basically deciding what is the main object of focus. That's the figure, and then what's the background to the ground.
So when I see a bird perched on a branch, the bird's the figure and the tree branches are the ground.
Exactly. Our brain makes that distinction based on cues like size, contrast, contour, and that helps us focus on what's important.
Okay, I see. This whole process is making me realize just how much our brains are constantly interpreting and organizing everything around us.
Oh yeah, it's a nonstop job.
So then the chapter talks about this thing called global precedence. What's that all about?
Global precedence, it's kind of like our tendency to see the whole before we see the parts.
Okay, that makes sense. Like recognizing a forest before you notice the individual trees.
Right. But what's really interesting is that this isn't always the case. There's research that shows that, for example, the Himba people of Namibia, they actually show local precedence. So they're focusing on the details first and then building up to the whole.
Oh, wow, that's so interesting. So even something as basic as how we process visual information, it can be influenced by our culture and our experiences.
Precisely. It really highlights how plastic our brains are and how perception is not just about our biology. It's also about like the environment we grow up in, our upbringing, all of that.
That's mind-blowing. Okay, so we've been talking about how our brains make sense of visual information, but what about our other senses? Do they all work together, or are they like separate channels?
That's a great question. And the short answer is they definitely influence each other. The chapter calls it multisensory interaction.
Okay, so my senses aren't just working independently, they're actually like talking to each other.
In a way, yes. Think about watching a movie. You're not just seeing the images, you're also hearing the sounds.
Right.
And those two senses, they're working together to create a much more immersive, rich experience.
That's a good example. The chapter also mentioned synesthesia, which I always thought was fascinating. That's where like people's senses get mixed up, right?
Yeah, it's a really interesting phenomenon where the stimulation of one sense can trigger an experience in another. So some people might hear music and they'll see colors, or they'll taste a certain food and feel a specific texture.
That's incredible. So their brains are making these like unusual connections between different sensory experiences.
Yeah, unusual to most of us, but to them, it's just how they perceive the world. And it really highlights how interconnected our senses can be.
That's wild. But even for those of us who don't have synesthesia, our senses are constantly influencing each other in these more subtle ways, right?
Oh, absolutely. Like, think about eating something. The smell of the food and the texture can actually change how it tastes.
You're so right. I never really thought about it like that.
Yeah, it's multisensory integration in action. And sometimes when our senses are kind of in conflict, one sense can actually dominate the others. And that can lead to some pretty crazy illusions.
Ooh, illusions. Now we're talking. Tell me more about that.
Okay, so it's called sensory domination. Have you ever noticed how, like, the sound of a movie seems much louder when you close your eyes?
Now that you mention it, yeah, I think I have.
Yeah, that's because when you eliminate the visual input, your auditory sense kind of takes over.
So it's amplified.
Exactly.
Huh. So our brain is basically choosing which sense to prioritize based on the situation.
Right, and that can also explain some classic illusions like the ventriloquist effect.
Oh, where we think the dummy is talking.
Precisely. Because our visual sense dominates in that situation, we perceive the voice as coming from the dummy's moving mouth, even though logically we know it's the ventriloquist speaking.
It's crazy how easily our brains can be tricked like that. And this is all just scratching the surface of perception.
Oh yeah, there's so much more. We haven't even talked about how our actions, our physical state, even our unconscious biases can shape how we perceive the world.
Oh, I can't wait to dive into all of that. This is turning out to be one of our most mind-blowing deep dives yet.
I agree. It's fascinating stuff. It really makes you appreciate the complexity and wonder of our own minds.
So we've established our brains are masters of illusion, like constantly playing tricks on us with our perceptions. But how far does this, like, rabbit hole go? The chapter talks about this really cool study called the rubber hand illusion. What's that all about?
Ah, the rubber hand illusion. Yeah, it's a classic. It really demonstrates how easily our brains can, like, integrate visual and tactile information, even when it completely conflicts with, like, our actual body schema.
Okay, that sounds intriguing. How does it work?
Okay, so picture this. You're sitting at a table, and one of your hands is hidden from view, and right next to your hidden hand is a realistic, like fake rubber hand.
Okay.
And the experimenter, they simultaneously stroke both your real hand and the rubber hand in a brush.
So I'm feeling the touch on my real hand, but seeing it on the rubber hand.
Exactly. And what happens is, after a while, people start to feel like that rubber hand is actually their own. They even report feeling sensations in the rubber hand when it's touched, even though it's their real hand that's actually being stimulated.
No way. So my brain is basically being tricked into adopting this fake hand as part of my body.
Yeah, pretty much. It really shows the power of visual capture, how our visual sense often just dominates our other senses. And it can even influence how we perceive our own bodies.
That's both fascinating and a little creepy, honestly. But it gets weirder, right? The chapter mentions something about this illusion working with amputees.
Yeah, that's right. Researchers have found that amputees who have lost a limb, they can experience the rubber hand illusion with a prosthetic hand, and they report feeling sensations in the prosthetic as if it were their own missing limb.
Wow, that's mind-blowing. So even though the limb isn't there anymore, the brain can still be tricked into feelings and sensations in it.
It really is amazing. It suggests that our body schema, that internal map of our body that we have, it's incredibly adaptable, and it can be influenced by sensory input, even in the absence of a physical limb.
I mean, this has huge implications for prosthetics, right? If we can trick the brain into feeling sensations in a prosthetic, that can make it feel so much more like a natural part of the body.
Absolutely. It's really exciting research. It's paving the way for, more realistic, more intuitive prosthetic limbs that can actually provide sensory feedback. It could really revolutionize the lives of amputees.
That's incredible. It's like science fiction becoming reality. Okay, so we've talked a lot about how our brains make sense of sensory information, but the chapter also delves into how perception is kind of intertwined with action. It mentions this concept of affordances. What are those all about?
Okay, so affordances, they basically refer to the action possibilities that an object or environment offers. So think about a chair, right? It affords sitting.
Makes sense.
A door handle, it affords grasping and turning.
So it's not just about what an object is, it's about what I can do with it.
Exactly. Our brains are constantly assessing the affordances of everything around us. It's what guides our actions, our interactions with the world.
It's like our brains are always looking for opportunities to interact with the world in meaningful ways.
Yeah, that's a great way to put it. And what's interesting is that our perception of affordances can actually change based on our current abilities and our goals. Like, have you ever noticed how a flight of stairs might seem so much more daunting when you're carrying, like, heavy bags?
Oh, absolutely. Suddenly they seem twice as steep, twice as long.
Right, because your perception of the affordances of the stairs has changed. Your physical state being tired carrying those bags, it influences your perception of how challenging those stairs will be to climb.
Makes total sense. So our perception of the world isn't just about passively taking in information. It's also about, like, actively engaging with our surroundings, making decisions about how to interact with them.
Exactly. Perception and action are super intertwined. And that idea is kind of further emphasized by this concept of embodied perception.
Okay, what's that all about?
So, embodied perception is the idea that our physical state, our movements, even our goals, they all directly influence how we perceive the world. So, it's not just our brains, like up in our heads interpreting information, our entire bodies are part of the process.
So my body isn't just a vessel for my brain, it's actually shaping how I experience the world.
Exactly. There was this classic study where researchers had participants wear backpacks and then estimate the slant of a hill.
Okay.
And the people wearing heavier backpacks, they perceived the hill as being steeper.
Wow.
Yeah, so it suggests that their physical exertion actually influenced their perception of the environment.
So even something as basic as how steep a hill looks, it can be influenced by how tired I am.
Pretty much, yeah. It's a great example of how our perceptions aren't objective. They're shaped by this whole complex interplay of factors, including our physical state, our goals, our past experiences.
This is starting to make me feel like my perceptions are much more fluid and adaptable than I ever realized.
They definitely are. Our brains are constantly updating our perceptions based on new information, new experiences, even our current mood and motivations. It's amazing.
Now, I know we can't really talk about perception without talking about consciousness. It's such a big, complex topic. How does the chapter even approach it?
Right. Well, they start with a pretty basic definition, defining consciousness as our awareness of ourselves and our surroundings. It's what allows us to have subjective experiences, to feel emotions, to make sense of the world.
Okay, that's a good starting point, but consciousness is more than just being awake, right?
Oh, for sure. The chapter talks about different levels of consciousness, from just basic awareness to more complex forms of like self-awareness and introspection. It also talks about how consciousness can be altered, by sleep, drugs, even meditation.
So there's a whole spectrum of conscious experience, from that hazy, just woke up feeling to moments of really intense focus and awareness.
Exactly. And what's interesting is while we often think of consciousness as this like unified experience, there's evidence that it might actually be more fragmented than we realize.
Oh, okay. What do you mean by fragmented?
Well, there's this famous case study of a patient, DB. He had damage to a specific part of his brain that processes visual information.
So he had some kind of vision impairment.
Yeah, he was blind to one side of his visual field. But here's the crazy part. Even though he couldn't consciously see anything in that blind spot, he could still accurately guess the location and even the shape of objects that were presented there.
Wait, so he was blind but could still kind of see.
Exactly. That phenomenon is called blind sight, and it suggests that there might be separate visual pathways in the brain, one for conscious visual perception and another for unconscious processing of visual information.
So even when we're not consciously aware of something, our brains might still be processing information about it.
It seems that way, yeah. And this really raises some interesting questions about the nature of consciousness and the limits of our awareness.
It's like we're venturing into the twilight zone of perception here.
It's definitely mind-bending stuff. And we haven't even touched on, the illusion of conscious will.
Oh, I've heard about that. That's the idea that free will might not be as real as we think it is, right?
Exactly. Some researchers argue that the feeling of consciously making a decision, it might actually be an illusion. They think our actions are often initiated by unconscious brain processes, and then our conscious mind creates a narrative to explain why we did what we did.
Whoa, that's kind of unsettling. So you're telling me that even though I feel like I'm making choices, my brain might have already made up its mind.
Yeah, it's a controversial theory for sure, but there's some pretty compelling evidence to support it. Like studies using brain imaging, they've shown that activity in certain brain regions can actually predict a person's decisions several seconds before they're even aware of making it.
Okay, that's both kind of creepy and incredibly fascinating at the same time. So if free will is an illusion, does that mean we're not responsible for our actions?
That's a big philosophical question, and there's no easy answer. But even if our conscious minds aren't always calling the shots, it doesn't necessarily mean we have no control over our behavior.
How so?
Well, our conscious minds can still play a role in shaping our habits, setting goals, reflecting on our actions. We might not have complete control over every decision in the moment, but we can definitely influence our overall behavior patterns through conscious effort.
Okay, that's reassuring. Consciousness is a complicated beast, but there's one last topic from the chapter I want to touch on. Subliminal perception. What's the deal with that? Is it real or is it all hype?
Subliminal perception. So that refers to the processing of information below our conscious awareness. It's the idea that we can be influenced by stimuli that we don't consciously see or hear.
Like those supposed subliminal messages in advertising that make you crave a certain product.
Exactly, that's the classic example. But while the idea of subliminal advertising controlling our behavior is mostly a myth, there is some evidence that we can be subtly influenced by stimuli that fall below our conscious threshold.
So it's not all a bunch of bunk.
Right. There have been studies showing that if you briefly flash a word or an image too quickly for someone to consciously register it, it can still influence their responses afterward, even if they're not aware of having seen it.
That's wild. So even though I might not be able to see it, my brain is still processing that information.
Exactly. It suggests that our unconscious minds are constantly picking up on all these subtle cues from our surroundings, shaping our thoughts and behaviors in ways we don't even realize.
This is making me rethink everything I thought I knew about how my brain works.
It's a trip, isn't it? A real journey into the hidden depths of our minds.
So, okay, we've got all this information, right, coming in from our senses. Consciously, unconsciously, our brains are working overtime to make sense of it all. But how much of what we perceive is actually an accurate reflection of reality? How much is our brain just interpreting? The chapter mentions this debate between the constructive view and the direct view of perception. Can you break that down?
Yeah, so the constructive view, which goes way back to Helmholtz's idea, unconscious inference, it basically argues that, we're not just passively receiving information from the world, we're actively constructing our perceptions.
Based on all the stuff our brains already know.
Yeah, based on sensory input, our past experiences, our expectations, our brain is filling in the gaps, making these educated guesses about what's out there.
Think about how you can recognize a friend's face, even if they're wearing a hat or sunglasses.
Right, exactly. You're not just seeing the parts of their face that are visible. You're using your knowledge to kind of complete the picture.
That makes sense. So what about the direct view then? How is that different?
So the direct view, which was championed by Gibson, he argued that the environment itself, it already provides enough information for us to perceive the world accurately. We don't need to rely so heavily on inferences or interpretations.
So it's more about picking up on the richness of the sensory data itself.
Exactly. Gibson talked about invariants. These are those constant properties of the environment that give us direct information about the world. Think about when you're moving through a space.
Okay, yeah.
The way objects change size and position on your retina, that gives you direct information about depth and distance.
So it's the world is already speaking to us in a clear language, and our brains just need to listen.
Yeah, that's the essence of the direct view, but like most things in cognitive psychology, it's probably not that simple. The reality is likely somewhere in between these two views. We're probably using both bottom-up and top-down processes, combining the richness of that sensory data with, what we know, what we expect, to create that whole perceptual experience.
It's like this constant dance between what our senses are telling us and what our brains already know.
That's a great way to put it, yeah. And that dance is what makes perception so dynamic and so adaptable.
Well, this has been an incredible deep dive into the world of perception. I feel like I've learned so much about how my brain works.
It's definitely fascinating stuff. It really highlights, the complexity and wonder of the human mind.
Yeah, and we've covered so much, from just the basic difference between sensation and perception to those mind-bending illusions that reveal how our brains work.
All those ways our senses can interact and even deceive us.
Yeah, and how our actions can shape our perceptions, and even how, consciousness itself might not be what we think it is.
And then there's the implications for things like free will, subliminal influence. Really makes you think.
It really does. So a huge thank you to you, the listeners, for suggesting this topic. It's been a blast exploring it.
Yep.
And remember, the exploration doesn't end here. Keep questioning, keep observing, keep marveling at the incredible power of your own mind.
Couldn't have said it better myself.
Until next time, keep those brains buzzing.